Oh, hey, how you doing? You want to see that ball and beam project, right? It's pretty sweet. Step with me over here. So this is the ball and beam project. You're going to have to do this for your senior design class. It's actually very interesting. Here we have a flat strip potentiometer which measures pressure throughout it. Right here we have our servo motor connected via 4-bar. We determined that a 90-degree linkage gives the most mechanical advantage here, so that's what we went with, just to make sure we can move the ball. Over here we have our Arduino logic board, as well as a breadboard here to piece everything together. And the last component, very interesting, is our potentiometer. This actually lets us control where we want the ball. As you can see right now, we have it set to 0, and our ball is sitting right here at the end of the strip. Alright, let's crank up this potentiometer and see how it works. Let's go right up to 9 here. Let's see where our ball goes. You can see the servo here is figuring out where it wants to be. Oh, it's getting closer and closer. It'll take a second here. And look at that. Right on 9 with less than half an inch of movement. That's really cool. Great. Now, let's crank this up to 12 and let's see if we can get her dead center. Now, 12 region a little finicky, so I might need to turn up just a tidbit more to get us right there. Look at that. That is perfect. That ball is staying right where we want it to be. Now, this has a lot of applications in the real world, but before we get into that, let's take a look on how it actually works. Step with me over to the board. Now, PID controls are very complicated, but let's start simple. Let's take a look at some block diagram algebra for a pretty basic PID.
Yeah, let's take this break and we'll come back and I will go over to console, do the further investigation.
I would really like to get an idea of everything happening.
Okay.
We can go get food.
Yeah, let's go get food. Okay, come back. We'll print the pages where they're at. And we'll actually read. Unless that doesn't help your editing.
Okay. Now let's talk about what some of this means. So for starters, our XRS is our input. This is the potentiometer. When we on that dial when we said where do we want it to go. Our X of S. Now this is our output. This is where the ball actually is. Our disturbance right here. This is coming in from our strip, letting us know where the ball is at this time. Now this output is where we want it to be, and this input is where we told it to go. So the whole point of this is to get XRS to equal X of S, meaning they're at the same position. So let's run through how we determine this. So we input our XRS, and we ask our disturbance here, where are we? We're going to do XRS minus disturbance. That's going to get sent to our PID. Our PID is going to ask itself, okay, well, I know I have to get to this distance to move there. What angle does our servo need to do to accomplish this movement? It goes here. The disturbance right here is calculated again, and then it moves to the transfer function where it takes the difference. Right here, the transfer function asks, well, now that I know I've moved and my now disturbance is at a new place and my input is still at the same place, what does the ball and beam itself have to move? After it figures that out, it sends that movement back to our XRS. We do our subtraction, send it back to the PID, the motor will move again, it'll recalculate where it is, because since the motor's moved, the disturbance is going to be different. The transfer function is going to determine where the beam has to move to achieve XRS equaling X of S down here. And this cycle continues until XRS is about X of S. Like I mentioned, PID controllers and block diagrams are extremely complicated. Take a look at this one over here. This is an example provided by Dr. Zhang. As a group, we use this to determine our gains for our actual ball and beam project. Wow, Rob, this code is really working great, man. I got a friend over here. You want to give him some insight? You might be able to help him out in the future.
Sure, Jay. Anything for you. So right in the beginning of the code, we were looking at just initializing the two libraries we have to use for both the servo and the PID. The PID library is where all the calculations are being made so the ball is sitting on the beam correctly. So then after that, we just initialize all the variables and the pins we're using. If we scroll down to the void setup is actually where the code starts working. So here it's reading what the position is, and it's doing that using the self potentiometer. And then once it reads the position, it calls out for the PID controller in this section to understand what the servo has to do and where does it have to move. Once it does that, it comes back and prints to the screen and gives you the location of the ball on the beam. And that's that.
Great, Rob. Thanks for that explanation, man. I think you've got about all you need for the ball and beam project.
Damn, it feels good to be a gangster. A real gangster type player plays his cards right. A real gangster type player never runs his mouth, cause real gangsterized players don't start fights.